let us get things under control. Okay. Close this up. Hello, everyone, and welcome to Handmade Hero, the only show that you can even conceive of watching, really. Like, if you really just had to, in your mind's eye, I'm sure you could envision no other show that could ever even possibly exist across all of humanity, where people code an entire game from scratch with no engine and no libraries. It seems impossible. How do they even do it? And yet, night after night, it is getting done with just me and 1,000 of my closest friends. How long will we be able to keep this up? It's anyone's guess. It's really, you never do know. It's surprises around every corner here at Handmade Hero, but that is certainly not going to stop us. We are going to continue until we have our own very little happy shining game that we can say we understood every last little bit of. And honestly, I think it's going pretty good so far. So why delay the inevitable? Let's just dive right into it. If you have pre-ordered the game, you should have gotten a link in your email with a zip file download sort of thingy from Sendal. You can download the source code every night from that. You can also download the test assets. If you download the source, it's a zip file that has a ton of zip files in it, one for each day. We are on day 52, so unzip day 51. And you put that in a directory and you will be where I am. So you will be like able to totally just scoot in, kind of like one of those bicyclists that drafts off another bicyclist. You can just totally go for it. No headwind. It's great. All right. So let's see. I was rudely interrupted by the timer last time, who told me that it was the end of the stream, because I was right in the middle of making some major changes to the code base. And so what I want to do is go ahead and get back to those changes so that we can emerge from the other side of our change tunnel in a wonderful, where the bright light is shining and the unicorns run free and the rainbows are, gluten-free and everything else that happens. All right, so what I was doing is I was changing it. I was starting to play around with changing things over so that we would have entities divided up into pieces where we had ones that were sort of in the close range around the player, 1 or 2 screens away from the player. Those entities would be stored in sort of a high form. I'm going to get rid of that exists because we replaced that yesterday with this non-existent flag. We stored in this high entity, and then we'd have low entity, which are entities that are being simulated but are further away from you and are getting updated perhaps at a lower resolution. And then we would have dormant entities, which didn't get updated at all. And so we were just kind of thinking of that through. Now, this is not set in stone by any means. These probably won't be laid out like this in the final version or anything like that, but I'm starting to play around because I want this basic structure, this basic concept anyway, that things get mapped in and out of sort of the working set around the player. And when they get mapped out, they're not totally dormant automatically. They could still be in sort of a low frequency update pattern, and that's where this would be. So let's see what's going on here. I think we were sort of in the process of, we were like sort of in the process of making the change, and we had to if zero a bunch of stuff out. So we have right now that move player. I'm going to go ahead and start working on some of this code that we'd if zeroed out. So when we do our move player code, now we really don't have to think about the tile map anymore for the most part. In fact, I really just don't even know if we're going to have to do anything with this tile map anymore, because really what we would have is we just have all of the tiles just be moved into that set as well. So when we come in, I feel like all of those tiles would essentially be sort of active entities. And the reason I say that is because I don't know that we really want tiles per se ever at all. We just kind of want stuff that's following the tile map. So, if we have trees, we probably just want the trees to be in there, and we want the player to collide against the trees and stuff like that. So I'm going to assume that we're actually just go ahead and I'm going to just make that change while we're at it as well. And so thinking about that, I guess what I would say is our entity structures will also, let's say, why not? Let's just say that our entity structures will also contain the actual tiles in them as well. And so if I wanted to do that, I'd have to start thinking about how I would do my collision detection, right? Because if I want to have entity on entity collision detection, which obviously we're going to have, we would need some way of binning them so we do some kind of a spatial subdivision to keep things obviously from getting too hectic. And so that would start to be sort of a retiling of things as well. And so that's kind of something to think about. It's like, it's kind of weird that we have all of these sort of different structures. And it does seem weird to have stuff like, oh, well, you know, why do we have sort of these different levels of how things get done? But again, it all tends to shake out in the end, and you have to kind of go through a number of different iterations of how you structure things until you get something that you're very happy with. And so it's all just, you know, don't worry about it too much. It's all just kind of the way things go on the road to getting something that feels good. And it's all about kind of seeing how that goes. So I think what we'll do first is just assume we'll test every entity against every other entity, which is n squared and really bad, so that won't be able to be used in the final version, but we'll just assume that's going to happen for now. And so we'll assume that what we would essentially do is just have entities for all of those tiles. And so in the high entity struct, that would be kind of a good argument against the way this dormant entity thing was working, where we had it backed, where we had them in parallel arrays, because we would want to basically have it so that they, the high entities could be brought in from other places. So I don't know exactly how I want to, I don't know exactly how I want to do that for right now, but yeah, I'm just going to go ahead and do it, and we'll see what happens. So if we were going to do that, right, then we no longer have to figure out where we are in this space anymore. We will have to do something like that when we actually want to we will have to do something where we have some kind of spatial partition. But for now, I'm going to ignore that. I'm going to say, let's just ignore this stuff for now. Let's get rid of that there. And then, in fact, we'll get rid of this as well, like so. And I'm just going to go ahead and say, all right, for every entity, so we have, you know, an entity index or something. For every entity in the world, right, I am going to go ahead and check to see what's going on with it versus this other guy. Okay, let's see here. Oh, and you know what? Really, that's something that happens inside here. So this is actually the iteration right there that we're looking at. So we've got, let's see, there we go. So we've got that there, and then instead of actually having any of the tile stuff, we're just going to get rid of all that. Let's see there. And then we're going to take a look here, and we're going to see what this does in here. So basically what I'm doing is I'm changing this into an iteration over the tile map, and I'm changing it into an iteration over the entities that are active in the region, right? So what I want to do is say, okay, we still have this iteration where we've got to go over some for each iteration. We've got to see what entities we're going to collide with. For right now, we're going to assume that we can collide with any of them, which again, like I said, is really inefficient, so we don't really want to do that. But we'll deal with that when we go through the second pass. And since all the entities are defined to always be in the same space now, we can kind of get rid of all of this stuff entirely. That's just gone. And now we are basically talking about just having to compute. So the diameter, width, and height is basically going to be pulled off of that other entity, right? So did we pass in? We passed in the entity that we're using. So now we just need to go ahead and get whatever the other entity is. So essentially we want to get the entity here. So we've got an entity, test entity, and that's going to go ahead and grab whatever entity we're on. And so when I grab that test entity, then I'm going to be able to test against its width and height, right? And so that's going to be the dormant version, like so, of our entity, and it's going to be the dormant version of the test entity as well, right? So again, we're doing exactly the same test that we were doing before, only now instead of doing against a tile, we're doing it against against the other entities. So before we were looping over each tile, now we're looping over each entity, and again, we have widths and heights for the entities, so we'll just use them. That seems pretty easy. And so then all we really need to do now is we need to come up with what we were using before, a relative, basically a relative position relative to, so we got the min core and the max runner. We just have to have the relative position between the test entity and our entity, and that's obviously very easy to do. That's just the high P and the test entity high P are the two positions. So if I subtract those two, I'm going to get the relative position of the player, right? So I can just directly do that, basically, right? So that's the difference between those two. And that is pretty much all I need to do there. We'll have to, again, all this stuff is a little sloppy. We'll come back through here, and I just want to kind of get everything laid out and think about it a little bit as we go. So again, looping over all the entities for each iteration of our collision solve, and we're seeing if we hit any of them, and if we do, then we just go ahead and process the collision like we were doing before. Okay. So when we come out of this, we should have a team in just like we had before. We will update that team in by basically saying, okay, the entity position is going to have added to it whatever that offset was. The velocity will obviously be clipped like we wanted it to be, so that it will no longer have any component if there was a wall that it hit, right? And then the player delta, which is the thing that we're updating by, will also get clipped by it, and we will continue our loop. So that's about all that really needed to happen there. The rest of this stuff can kind of work the same as it was before. This stuff is for going up and down, right? And so I believe what we want to do here is say, okay, when we're doing our collision checking, obviously, inside here, we may find, we basically need now to have some concept of what our collisions actually do, whether or not those collisions are things that actually stop the player, or whether they're collisions that cause something to happen, if that makes sense. So while we are iterating here, right, every time we hit an entity, it would be nice to remember which entity it was that we hit, right? So if I have, for example, an entity or a hit entity index, right? And remember, 0 is the null entity. In fact, I can always start all of my entities iterations at 1. I always forget that we have a null entity. So if I have my hit entity index, assuming that I have a hit entity, it does kind of mean now that we could do something like, okay, if hit entity index, right? If something's going to happen here, we could go ahead and see whether or not whatever that entity was had something that was supposed to happen when we collide with it, right? And I'm not sure exactly what we'd want to do for that, but you know, if we were talking about something that was like a doorway or whatever, we could easily put something in here, right, that says, you know, int32 d abs tile z, right, again. And this is kind of, what I'm doing basically is sticking all of the things that I want into the entity structure for now, and then we'll sort of see how we want to start peeling those off a little bit later, right? So like this is for stairs. And I guess we should put stairs in quotes because we don't really know what we want to do for stairs. Or rather what they'll actually look like in the game. We don't know if they'll actually be stairs. So all right, so what we could do is say, all right, if we hit an entity index, then is that entity index something that we need to process? You know, does it do collision response, or does it do some other magical effect, right? And so what we could do is say, another thing we could say here, right, for example, is collides, right? Or collides with, you know, I don't know, we'll just call it collides for now, right? And so what we could say is, well, if the test entity, if it collides, right, then we're going to do some testing. But if it doesn't collide, then we won't, right? And so once we do the hit entity index, we know that it is something that does collide, and then we could go ahead in here and say, well, this is where we would process our collision response. And we can sort of save a little bit work here because we know that if we didn't hit any entities, then we know that these things are not in play, right? So we could go ahead and say that, you know, that we only do this in the case where we actually hit an entity, and otherwise we just break out of our collision loop altogether, right, immediately. So we could do that. I don't know if we want to do that, but we could do it, so we might as well. All right, and so if we hit an entity index, then it might be nice to go ahead and, after we update the player position, see what it actually is that we want to do when we hit this particular entity, right? So when we hit this particular entity, right, we're going to go ahead and get it. So I've got a hit entity here. And then I'm going to say, well, all right, now we don't need to know, we don't need to know most of this other stuff. So we can just go ahead and do whatever that tile stuff was up in here. We don't really have to care about this stuff. Let's get rid of that. And then this stuff is updating the facing direction. And this, I think we want to change this to be using the acceleration vector. But we'll just make a note of that. We'll worry about that more when we get to animation. All right, so if I'm doing this and I go ahead and get that hit entity, right, and then I should be able to say, all right, well, the entity P abs tile Z, so that's going to be in this dormant state, right? His absolute tile Z is going to have to change now. And if I change the entities, the position of the guy, the camera will have to change as well, but that's actually fine. So I think we would move his abs tile Z up. And the only question I have here is how do we want to deal with that with the high entity versus the dormant entity? So I think the problem here, if I may, is really that these coordinates I want to really be kind of three-dimensional, if that makes sense. So I really want these guys to be 3D. Since they aren't right now, I'll go ahead and say that the abs tile Z is actually in here so that I can update the high one. But eventually what we're going to do is we're going to extend these to V3s, which may have to happen relatively soon. I definitely want it to happen before we get to animation, but that's something we'll have to deal with in a moment. Okay. So I'm going to go ahead and say, all right, the high entity abs tile Z is going to get plus equaled to whatever this d abs tile Z is here. And that's the entity dormant d abs tile Z, obviously. Oops, wrong way there. And that's how we'd implement stairs. Now, again, you can sort of start to see, I mean, you can vaguely sort of start to see what we're going to be doing eventually here. You can already sort of get to feel for it. After we start piling enough stuff up in here, it'll be like all of the things you'd ever want to do on collision response would all be in here, right? So you can already see that this is a place that we're going to want to start to focus our attention in terms of starting to support multiple types of entities and that sort of thing, so that we don't have every single possible thing that could possibly be in an entity getting stored and getting processed and all that stuff, right? So you can sort of see how things will sort of start to indicate to us how we need to start to break down the architecture. But at this point, obviously, it's totally fine, but you can kind of see it already starting. This is where we'll have a bunch of data, and we'll want to start to marshal that data, sort of keep it under control in different ways. And so that'll be very interesting when we get to that as well. But we're not there yet. So anyway, that's right. I forgot we have to pass, at least at the moment, we're passing what kind of entity resolution we want for things. So for now, we're doing it this way, but we're going to have to do some other, we'll do some other interesting things. We might even get to that today, we'll see. So let's see here. We have our entity, and that's obviously supposed to be that in the high P. All of these are entity high data. There we go. Entity high, right, and so on. And that all looks good. Oops, that doesn't look good. And this also has to have that same guy. We obviously want to get the entity at high resolution. Although actually we only really need them at dormant, now that I think about it, because we're not actually doing, oh no, we were doing the, no, we're just doing the, yeah, we were just doing the dormant access, so we can just get them at dormant level. All right, so let's see what else happens here. These are just ones that have to be changed to entity.high again, right? Oops, entity with entity.high. So that's just changing it like that. Okay, and there we go. Oh, wow, that compiled the whole thing. I was expecting more of a fuss than that. I guess not. Okay, so we have a ton of work to do still because we haven't really done all the stuff that we need to do. So, for example, change entity residence has not been implemented yet, right? And so you can see we were trying to initialize the player and bring him in there. We haven't done that. We haven't actually put any of the walls into the entity list. So yeah, so stuff's a little banana cakes right now and not in a particularly good setup whatsoever. So what we need to do first is say, all right, when we do change entity residence, we have to take a look and see what is going on with the entity. Right now, we actually only have one thing that we really need to handle, or I should say two state transitions we need to handle. which is basically if the residence equals high, right? Then we need to move him from dormant to high if he was currently dormant, or rather just not in high. Else, if the residence equals entity residence low, that means we're moving him out, right? That's really all we really needed to do. So what we can do here is say, all right, if the entity residence equals entity high, or sorry, is not equal to entity high, then we know that we have to do the move. Otherwise, we don't have to do anything because he's already resident in the place that we want him to be. And if the residence here is not equal to low, then the same is true. But, or I shouldn't say low. It's actually dormant that we care about here. And then I guess we'll say, well, I guess it's really if it's equal to anything else at the moment. We'd have to think about what would happen with when we start to have something actually in low. But at the moment, everything's actually in the dormant. And I wonder if maybe low entities maybe just wouldn't have hardly anything else in them. So it may look more like if the residence, either it's high and it wasn't high, so it has to move to high, or it is anything and was going to be high previously, right? So it was, it was anything if the residence was already equal to high, I guess we could say. So if it's high and it wasn't high, then we need to make it high by translating it up into the camera space. So map the entity into camera space, and if it was something other than high, and we want, and it was, if it was high and we want it to be something other than high, then we need to map it, the entity back into tile space, like so, right? So yeah. So that's really all we need to do there. Pretty straightforward. Okay. And I can already think about I'm already thinking of some things that I want to do that or at least that we're going to have to think about that I don't quite have captured here. Like the thing that I'm thinking about in my head is, what if you almost want it so that you can ask for either one of these, and it's almost more like a caching system, if that makes sense. Like I'm thinking about it and I'm going like, I don't really want to have to worry about what state it's in so much as I want to just be able to ask for one of these types of data. So if I was computing in tile map space, I could ask for the dormant entity and guarantee that that would be a valid position for him. Even if he was currently high, because it would do the reverse mapping at the time that I asked if it was stale. You know what I mean? So it's a little confusing. So I got to think that through. Or I might just do it so that I always map them back immediately after. Like another thing we could do, right, is that when we do the move player, at the end, we always just do the reverse mapping just at the end of that move player. So we could always just update it up here. So every time we move somebody, we update them just at the end. So that way it's all in float, but you always write back a valid tile position at the end. You know, that could be kind of interesting too. Always write back a valid tile position. Right, because then everyone who wants to execute slowly on dormant or low entities can, and anyone who wants to go on highs could as well. It's kind of compelling. Kind of compelling. You know what I'm saying to you? So it'd basically just be, we would have no more concept of recanonicalize either. We'd just have a thing that flat out maps by doing it directly. Yeah, I think that sounds really good to me, right? Because you can see how that works. Basically, everything happens on high entities, and they just get pushed down to the dormant entities, right? And then you know that the dormant entities are also always valid. So you don't have to worry about the fact that something wouldn't have a P that was valid. So I think that's, yeah, I like that. I like that. I like that a lot. And so basically, what that means to me as well is like the change entity residence, right, is only going to really do this case, right? It never has to map it out at all. This change entity residence will become mostly about just managing the actual lists of entities, and it won't really be very much about doing those mappings. The only time it will do a mapping for us is when it needs to generate the high entity out of the dormant one, right? So that's kind of cool. I like where this is going. I'm already liking this. And again, I just want to kind of point this out. I've said it a billion times. I'm just going to say it again. That's the reason why I code this way, is because I never would have thought of all of these things correctly, right? I just never would have. I need to go through them and see how they work and then come up with them. And so I try very hard to structure my programming technique around being able to iterate on a number of little design ideas like this. And then when I know that I've got one that's good, then I blow that out into the full design, right? And that just saves a tremendous amount of time over trying to pre-design everything up front, where I will always be wrong, and I kind of feel like everyone I've ever seen do it is also wrong. I don't think it's like just me. And so just trying it first and doing it that way is much better. Because remember, it doesn't take that long. We only spend a few hours doing this sort of stuff. If you count up the amount of time we spend doing it on the stream, any given thing that we're prototyping is usually only 2-3 hours at max, right? And so if you think about how little time that is to invest towards exploring and figuring out what your architecture should be, it's so easy. I mean, you know, people spend that long just drawing diagrams, right? That are not useful. And so playing around with code is just a really good idea, I think, for figuring out how something should be designed. So I guess what I want to do here is I want to calc the P. So what I want to do is I want to say that the entity dormant P equals map, map into tile space or something like this, right? And then what I do is I would pass the camera that we're using currently, and so that's this guy right here, right? So this is the base point. So yeah, so game state camera P. So that's the base point, and then my entity high P is my current point, and I'll just trust that that will always generate, you know, a valid sort of position there, right? And that way I know that those will always be valid as well. And that'll be pretty free to do. It's like, you know, 2 divides or something like that per entity. And we're already doing so much work, obviously, to update entities that I don't think that'll be particularly relevant. Okay, so if we go ahead and do that, man, I really like typing doormat, by the way. So now we've gotten rid of recanonicalize, right? It's gone. And our recanonicalize function is just going to be that mapping function, right? So in fact, we can even just kind of lean on the one we have already. So map into tile space, right? This function is now just going to be this, right? So we're going to have to pass that tile map. Tile map. That's just going to be map into tile space, right? Oops. Not that one. Map into tile space. And all we really have to do is say, okay, we've got that base position, and then we've got an offset, right? And that's really easy because we already essentially wrote this function. All we really have to do is we don't even have to do the work, right? All we really have to do is just that, I think, right? So basically we take that base position, we treat it as if we had updated it, and then we go in here. And by the way, I think these were busted, right? Remember, we didn't really need those. If I remember correctly, that was just a garbage thing that we'd done because we had forgot to call recanonicalize or something like this. I don't know, there was some nastiness going on there, so we're going to get rid of that for now as well. All right, so let's go ahead and see if we've got this correctly. Not a member of tile map, right, it's the offset there. And recanonicalize position, we don't care about this anymore. Let's see, and it isn't. It isn't. That's right, it's not. It's world. There we go. So let's do that. And I guess that's pointer as well. All right, so that is that. Now, what should happen, I guess, at the moment is we still have one more thing to implement, and that is the change entity residence function. That has to go ahead and actually map things into entity space, into the camera space. So wherever that camera P is, right, what we need to do is say we need to do that difference, that tile difference that we were doing before. Right, here we go. Let's see, tile map difference. We need to do this guy. So we got to take that difference. Where is that function? It is subtract. And so we are going to subtract the entity position, and that's the dormant position, from wherever the camera is at the moment, and that is going to be where the entity now resides. All right. So, oh, and that needs the tile map. So let's see. We just did a ton of stuff. I feel the need at the moment to kind of step through here and kind of get our bearings a little bit. These are addresses. There we go. So that diff now needs to have our entity high, has to get initialized. So what have we got here? Well, oops. Well, our entity high now has to have a p, which is just going to be that diff, right? So that's the xy. Our entity high dp is going to be nothing. We'll just assume he has no velocity at start, which may be something we want to change in the future, but we're not sure. Its abs tile z is just going to be whatever its z actually was, right? So that's going to be abs tile z there. And its facing direction is just going to be 0, I guess. We'll assume that gets updated at some point. What was the actual name for that? dxy. There we go. So, all right. So let's see what's going on now, because we've made so many changes at this point. Oops, devenv. MSDev was the old name. They changed it to devenv. Don't ask me why. Nobody knows. So let's take a look at what's going on here, because who has any idea at this point what's going on? So what we would want to start with is we'd want to start with the point where a player actually becomes active, right? So I hit the space bar, and we're going to add an entity. We go through here. It's going to be entity 1, which is correct. That's what we want. I would like to turn hexadecimal off, please. Thank you. And that's going to go ahead and clear all of the stuff out, which is fine. And we're going to set it to dormant, and that's about it. Then we're going to initialize the player, so we're going to go ahead and get that entity. And let's see here. We got all of the versions of it, even though it's technically still dormant. That's okay, because we're not actually doing any kind of compression with that yet. We're going to set where we think that it is. And, you know, we haven't actually set... Did we actually... I guess we did set the camera position as well. So then we're going to call change entity residence. So we come up here, we say if the residence equals high, which it does in this case, but it wasn't equal to high before, then we need to do our initialization of the high entity. So let's take a look. Where is that? It's -9, -1. Those are relatively reasonable values, I would think. And we're going to set that abs tile to wherever it was, facing direction. So we've done that. And since there was nothing else, we're going to set the camera to follow. And we're going to have to go, we have to go update that camera follow code, because I don't think we ever actually did that. All right, so that's all we did there. And then we should be able to kind of, we'll step through it a little bit more and see. All right, so when we're doing this rel row rel column nonsense now, so this stuff is going to go away as well. I think in a second here, we'll find out. So let me skip through here. Anything that's entity residence high, which is the first one and the second one, neither of them were. Oh, did we forget? You know what? I think we forgot to actually ever set the residence. Change entity residence. So what we need to do at the end of this is say entity residence equals residence. So otherwise it'll never get marked as high, which is not what we want. Okay, so let's try that one more time. Let's see what happens. So we want to go down here to there, and let's see what happens here. So if we do this, and I hit the space bar, I am still not even triggering a breakpoint. So why is that the case? Did we or did we not add an entity? I guess we did not add an entity somehow. So let's find out. Oh, right. Oh, that was funny. That was funny. Yeah. If that doesn't change the entity residence, that's just a note of what the residence is. We actually need to do it here, right? that's actually where we need to change the actual entity residence. So I'm guessing that really what we want to do for that is that should probably be, we would put that in the dormant part after, I suspect, because there's really no need for having an extra one here since we always have to have the rest of the entity data. But yeah, I don't know. I don't know. Yeah, well, so there's a couple things we need to do. So let's do them both. So first of all, let's change this so that when we do the change entity residence, we'll actually just do this. In fact, you know what? We don't even really need change entity residence to do that, really, right? This is actually going to be here, and this could actually be something that's just taking the uint32 of the entity index. So this is going to go ahead and say that entity residence, like so, is of the entity index equals the residence, right? And then this entity high, it's only going to probably ever have to, well, no, I guess it needs to do the rest of it too. But that's just going to go ahead and do these two. So in the case where these are here, we have the high entity equals game state high entities, entity index, there we go, and the dormant entity equals game state, dormant entities, entity index. All right, so we've got those. That's all happy. We'll change this to look like that, Okay. So that'll do that, and I'm just going to have get entity say if the residence that you requested is less than the residence, or sorry, is greater than the residence that the entity currently is, right? Then it'll do that change. So the first thing it'll do is say, okay, here, yeah, because this is garbage, in fact, what this is doing. This is not actually what it should be doing, right? Because this was just filling in whatever the residence was. What we really want to do is say if what we were currently residing at, right? If the current residence, like so, if the current place that we are residing is not where we want to reside, right? So if it's less than, then we need to do that change entity residence, right? To make sure that it's not anymore. And then we can know that it is, so we could assert here that it was, right? That these are equal after the fact, right? Or I shouldn't say equal, the entity residence is at least greater than or equal to, because really we could allow that function, that change residence, to change you at its discretion to a higher level of residence. We just don't want it to change you to a lower level of residence. So that's what that does, right? Okay. So all we really need to do now is figure out where is that residence again. That residence is here. So what we need to say is if the entity residence as it exists is not equal to high, then there we go. And let's see, change entity residence. This takes an entity index now. Yeah, and there's some stuff I don't like about that. Too many indexes versus struct thing. So we're gonna have to look at that a little bit more, but doesn't really matter at the moment. Okay. So that should be now, I think, changing it so that we actually have an entity. Okay, we do. And let's take a look at what that entity actually looks like. High entity, low entity, dormant entity, right? And here they are. So there's the offset of the guy. Here's his facing direction. Let's see what happens here. There he is. He's moving around. Now he should be able to walk straight through walls, which is true, because of course we're not adding those entities yet, right? Now if I add another guy, I feel like maybe they would collide now potentially. Maybe not. No. So I would like to I'd like to go see why that isn't. So that I think should be working. So let's debug that, because that is the one collision that I do think should probably work. So let's take a look. So what should be happening is when we do our collision iterations here, right? We should be testing with, oh, and you know what else we kind of need to do as well? We need to make sure we don't collide with ourselves. Let me do that first as well. Why do I keep closing the app? I have to remember to stop closing the app. I never need to close the app. I need to fix the thing that I was working on at work so that it has the hot reloading as well, so I just get used to never having to close apps anymore. You should never really have to close them. All right, so what I want to do is say, don't use the index that we are, right? So, you know, and that's pretty easy. I could just test the pointer as well. So I could just say, all right, you know, basically, if test entity.high is not equal to entity.high, something like this, right? That'd be a pretty trivial way to avoid testing against oneself. All right, so off we go, and keep that guy going there. Let's move this guy over here, right? And this, I assert, should be colliding. It isn't, so I think that's just a bug, right? So I want to see and make sure that we're actually, okay, so the first time through, we wouldn't try to collide with that guy because it's us. The next time through, there we go. It is not set to collide. That would be it. So when we add a player, we want to say collides is true, right? And now maybe they will collide. I don't know. Hard to say. Very hard to say, in fact. Off we go. There we go. And so we'll move this guy in here and see what happens if they collide. They do, in fact, collide. Yes. Although it doesn't quite skate properly. So we still have some bugs in there. Again, the collision detector is pretty bad at this point, so it's really not that big of a deal, but that should not be happening, I don't believe. So we should go double check what's going on in there. I think that might just be, again, with the, I don't know if that's more with the epsilon issues and so on, because like we haven't really done a good job making our collision detector do anything that you would want it to normally do to keep things robust or good. We only did like the very bare minimum. So, you know, if this was something a little more conservative here, I wonder if that would also keep us out of the woods until we actually go ahead and make a real collision detector. But let's see. Yeah, so the sticking is definitely not right. But at least you don't get epsilon trapped anymore. Yeah. So what's going on with our sticking? What is the problem? Did I inadvertently muck up the code when I came in here? So assuming that I hit an entity, if I didn't hit an entity, oh, do I ever actually set that? Of course not. Duh. All right, so that's our only problem. Hit entity index has to be equal to whatever the entity index was, right, that we actually hit. So there we go. That's really all we needed. We weren't actually ever processing that case. So yeah, of course, this is actually stuck in the guy now. That's pretty funny. Well, that's actually not that big of a deal to fix, right? I can just do this, right? Conditional expression is constant. I know. Well, if entity index equals 0, there we go. Now I can get out, right? And then, yeah, I may have to fix the collision detector. It's bugging me enough that it's not robust enough yet that it's already bugging me a little. But okay, at least now gliding is working properly. So we can at least get that roughly okay. I hate leaving things broken, but sometimes I know that it's better to leave them broken when you're not trying to actually ship them. You may just be wasting time, and so it's good to not do that sometimes, and I can appreciate that. Anyway, so that's good. That guy's colliding properly, so that's nice. And so now let's think about what else we need to do. So we've done our mapping, and everything is now happening in float space, which is good. That's all very nice. But we also now, let's start to look at what we have to do for the world itself and also for moving the camera. So like, let's try to put doors in there. Let's try to put stairs in the walls and that sort of stuff, right? Because we haven't done that yet. So assuming that whatever the camera following entity is has moved, that's one we should look at, right? To be sure. So what we want to do here is make this work entirely in camera space, like our to-do said. So what we want to do is say, all right, well, we already know the stuff we were computing with that diff before. We already know where the guy is relative to the camera because his high position is now exactly that, right? So all we really need to say is, okay, if the camera following entity high position, right? If the camera following entity high position is, if that is greater than however far we allow him to walk, then we know we need to move. The same is true, right, for the other directions. These are all exactly the same checks as they were, right? No big deal, py, and so on. So when we do these checks, we now will move the abs tile x, the abs tile y. We'll move all those in the right direction. So what we need to do is we just need to take whatever that difference is, however far the camera moved. So this is the original camera P, right, or the old camera P. We'll do whatever updating we need to do to follow the guy, and then we'll take a look and see whatever whatever that camera's position is now, we need to update all the entities by that, right? So we basically need to say, okay, let's take a look at what that tile map diff was again. Let's see, what is that called? Tile map difference. So we need to do tile map difference, and we will go ahead and say from the current, right, camera P, we'll subtract away whatever the old camera P was, right? And that gives us how far we have to move everything. That's right. That's how far the camera moved from its current location to its new location, right? So if that's the direction that the camera moved, then what we want to do is we want to move everyone else by the opposite of that, right? In other words, this is the D camera P, and what we want to do is have like the object offset, right? So the offset that we're going to apply to all of the entities, so the entity offset, is going to be the opposite of that, right? To give you some perspective of what I'm talking about here, we have the screen, we know that the camera was here, and then we did something, and we're going to say, okay, the camera goes here. So entities that were here, right? When the camera moves, if we were to apply the same translation, they would move with us. But that's not what we want. We're moving away from them, so they should be the opposite direction, right? So we want to basically move them the other direction so that when we render them, they'll appear to have slid, if that makes sense. So we want to move them counter to the motion of the camera. So this is basically D camera P dxy, right? That's what we're going to do there. And then we just loop over all the entities, and we loop over all the entities and apply that. And what we could do if we wanted to actually is we can roll that in. We can just straight up roll that in to our update loop. Actually, you know, we could just do this. We could just do this. So v2 entity offset, you know, for frame equals nothing, and then we compute it in that case, right? And then when we're in here, when we grab that high entity, the first thing we do is just say, okay, high entity P plus equals entity offset for frame. Makes sense? Seems pretty reasonable. These got to be addresses, of course, and that has to be an arrow. So I think that's all that has to happen for updating those guys. We'll drop an entity down there, and then we'll drop another one in here. Oh man, they spawn in each other, then they can't leave because the wall prevents the collision. So lame. I gotta fix that. I mean, not that you should ever spawn inside someone, but obviously just the way the collision detector works is just a little wonky there. So yeah. So now that's correct, I believe. And so what we need to do now is, oh, we wrapped, which we don't allow, by the way. What's that tile rel? Tiles greater than, yeah, so we don't, since we don't support wrapping, we can't walk off the bottom side of the screen yet, right? Or the left side. That's a massive faux pas, I suppose. We'll have to go ahead and move ourselves to the center. That'll be a good thing that we can do as well for getting us into the position that we want to be in for storing stuff sparsely. So yeah, that's all good. So now we really just kind of need to, I guess one thing we could do is we'll start by making doors. These guys work again, the stairwells. Also, shouldn't we be able to find some other part of the world here that had stuff in it when we came back downstairs? There should have been a place where we came back downstairs, right? Yeah, here it is. Of course, I don't know where it comes back again. I'm lost. It really would help if we had more backgrounds. There we go. Yeah. So yeah, I guess what I'll do, since we're at the 5-minute warning, I won't try and do that today. But that's basically, I guess what we'll do tomorrow is we'll start by starting to deal with putting the walls and the stairs, I should say, in there. That seems like the most logical next thing to do. And then at that point, we should have ourselves in a position to kind of take a step back and look at what's going on with the entities and with everything else, so that we can maybe turn the crank one more time on that and do a little more stuff like, you know, like I said, maybe let's put some monsters in here, let's put some hit points in here, let's put some, you know, some gamey stuff in there, so we can start to see how that entity struct shapes up and maybe play around a little bit with how we want to structure that. But yeah, so, and we'll try spamming out a lot of entities and having the dormant array and the non-dormant array. Like we'll just try all that stuff a little bit, just to kind of get us to the point where we're relatively certain that we've got things shook out as much as they need to be. I suspect I want to do a couple more things to that high dormant low structure once I have some people simulating out like in the world that's not on camera and so on. Yeah. So what we need to do now is let me just put in some to-dos for tomorrow so we know what we're doing. So basically what we need is we're going to need some functions here, right? We're going to need, like, when the camera moves, so in the case where the camera moves, like there, to do Casey map new entities in and old entities out. Whoa. I forgot I got that zoom feature. Move entities out. And we also want to do some stuff with mapping tiles and stairs into the entity set. And then we'll be good. So I think that's about right. And that is what we will do tomorrow. Okay, we're a little early, but that's okay. I don't want to start something else now because it's going to be a relatively major something. So let's go ahead and go to the Q&A. Please prefix your questions with Q:, so I will see them, and please keep them to be stuff that we did on today's stream or that we did on a previous stream so that we don't get off topic. If you want to do off-topic questions, come about 15 minutes before the stream starts, and we will talk about them then. Let's see. Do we have any questions? That's the real question. The real question is, do we have any questions? Why can't infrequent entity updates happen in the entity's update logic? That's kind of a slightly odd question because what we're talking about here is really when the entity's update logic gets called, if that makes sense. So the reason that I don't want to have to, so, if you're thinking about it like, something like this, the sort of the old school object-oriented way, where you've got something like this, happening. Any logic that you put in here is inherently pretty problematic, right? And the reason that it's problematic is because frequency update logic that goes in here, you have to call them all. So if I wanted to scale the number of entities to a very large number, like let's say I wanted to scale to 100,000 entities or something like that, right? Well, now I have to make 100,000 virtual function calls just to find out whether or not the entity should get updated, right? And that's just very inefficient, and you can pick the number, whatever the number is that you want, depending on how fast the machine is, obviously. You're not going to scale properly. So what you want to do is you want to make it so that you have some kind of a concept outside from the entity of which entities need what when, right? And so by breaking it into at least 2 tiers, I don't know if we'll have 3 in the end, but at least 2 tiers, high frequency and low frequency, right? We know that we can always scale up the number of entities and not have to worry about performance, CPU performance. Now, memory footprint's another question, right? How much storage we have for entities is a separate issue, right? But we won't have to worry about performance because we could always scale up the number of entities by updating them less frequently, right? So we are free to make that trade-off. With the virtual function call method, you can't make that trade-off. You've completely given up the ability to make that trade-off, right? Because just the act of looping over them and issuing the virtual function call is too slow at some breaking point. Whereas we won't have that problem, right? We can scale up almost ad infinitum, and you just won't pay for it. As long as you set that tick frequency to be low enough, it'll still work. It'll just get less accurate, right? And that's a much better place to be. Why do you want to use a 3D vector for position when the z value is always going to be an integer? So I don't think it's going to always be an integer. That's the reason why. I agree that if it was always going to be an integer, it would be kind of dumb. But I don't think it is going to be. So here's what I think. What I think is we're going to have a problem. Well, we already have the problem, but we're going to have to solve the problem. Let me put it that way. And basically that is, we've got dudes, right? We've got our hero or whatever. And he's walking around. And if you think about the way that he is structured and the way that other things in the world are structured, like, a tree or whatever, we want to be able to do stuff like have him jump, right, or bounce. So he might be off the ground, right? So if this is the shadow of the guys, right, and here we go, right? And so now he's got air, right? He's jumping up and down or whatever, right? So think about all of this and think about how this works. We're going to have to render him so that everything occludes properly, right? We're going to have to render him so that if there's a tree and he's in front of the tree, right? If he's in front of the tree, then we don't want anywhere where he is, we don't want the tree to be obscuring him. We want him to be in front of the tree, right? We want, I don't know if this eraser works. Let's find out. No, of course the eraser doesn't work. Why would the eraser work? It's only 2015. There's no reason why a drawing program would be able to have the eraser work on a pen. So anyway, so we want him to be able to occlude the tree so that you don't see what's behind him, right? So if you think about it, how are we going to do that? What's our cue? How does the engine even know what's in front of what? And the answer, one pretty trivial answer is, well, the y coordinate tells us something about where things are, right? Because things that are higher up on the screen, right, are back further away from the camera in our mental model, right? In other words, when we're doing this, right, and we have this guy here, and we move this guy in front of him, that looks right, but that looks wrong already. You know what I mean? So we know that things with a higher y, we're going to have to start drawing them behind things with a lower y. So the lower the y is, the closer to the camera it is, basically, right? Does that make sense? Hopefully I'm not saying anything here that's totally ridiculous, and this all makes fairly reasonable sense to you. So what happens now when we start talking about jumping? Well, if this guy jumped such that his y was up further, here or whatever, or something like that, we don't want him to draw behind the tree, because he's still in front of the tree, he's just jumping. So the y coordinate alone is not sufficient, right? What we really want to know is that there's a y base point, and that base point is sorted, but then there's also a z, which essentially translates the y upward and gives it a higher y without actually changing its sort order. So I think we're going to have x, y positions for people plus a z position for sprites and whatever. And the same would go for flying entities, like, if there's a dude with wings and he's flying around, right? That to me is what I think would probably happen. And so what I want to do is switch to using x, y, z, and then the z values will just work like everything else. There'll be some height where if you go above that height, you have walked onto the next tile map slice. And it'll just work uniformly with the x and y. That's my hope. We'll see what actually happens. Does Minkowski collision detection have to be axis aligned? No. We implemented a very simple algorithm, a very simple version of a Minkowski collision detector. Like I said, it's not very good. We'll be doing much better stuff as we go further in the stream. I just want to do something to get a collision detector in there because I don't think we need much of a collision detector right now to prototype stuff. But later, the one that I assume anyways, I don't know till we actually get there, but I assume the one we'll do later on the stream will actually handle rotation probably just fine. I don't know if we'll actually use it for rotation. We'll probably use it more for shape variance so that we can have circles and that kind of stuff. But the same technique would work for rotation. Just not animated rotation. Okay, no more questions? That is it for questions. Well. Very well. I guess we will end early tonight. Seems like it. I'll wait a couple seconds more just to see whether anyone has one. Didn't you just implement a bare bones relational database? Do you think that's a good mental model for understanding today's code? Well, that's an interesting question. So I have implemented an entire game engine before by writing a relational database at the bottom, that was like at the bottom of it. And what I would say is it is relational databases in general isn't really much of a statement. Like, a relational database implies usually a bunch of additional stuff if you say it to most people. Like, they're thinking SQL, they're thinking query-based stuff, and a lot of that isn't necessarily relevant to what we're doing here. But if you're literally just talking about the concept of a relational database where you have a key and you can pull things on a key and you can gather from multiple tables, then yeah, I mean, that is a very good mental model for things. Unfortunately, if you think about it too much in terms of the way that they're often implemented or exposed to the programmer, in today's world, it becomes not such a good model. And the reason for that is because a lot of things that you want to just be able to do with pointers and graphs and stuff are really not representable in query languages like SQL. And so, you end up with all these ridiculous things like stored procedures and just all of this garbage happening that you just don't want. And so I guess what I would say about relational databases is that if you're thinking of it literally just as maybe learning some of the first principles of relational database storage might be a useful way of thinking about it. But if you're thinking about it like SQL, that's not such a good way, right? Because SQL is just kind of not good. But I mean, hardcore relational database people don't think SQL is good either. Well, I shouldn't say that. There definitely are hardcore relational database people who think that SQL isn't very good either. So, that's hardly a surprise, right? I noticed your characters do not collide with each other. I thought you changed that. No, it does collide. It's just we are only, at the moment, we're trying to decide how big the player's footprint is. And right now it's just those rectangles. So it's just the little rectangles that collide. And you can see that they do actually collide at the moment, right? Does that make sense? So those are what collide. Now we will allow the player to walk through, like, for example, that is a totally valid configuration for entities, even in the final game, right? You don't want to prevent them from you don't want to make it so that it collides when it gets to here. That doesn't make any sense, right? Because since these things kind of overlap, you want them to be able to get overlapping in Y like that, if that makes sense. So I think this is basically what we want. The only thing that I was pointing out that we need to do is we need to start, when we do our render, we need to do that sort of sorting by Y so that we can make sure that we draw, when you go behind something, you draw behind it instead of in front of it. Right now, it's just drawing them in whatever order the entities come in, right? And that's not very useful. But the collision is working properly. How good is this addressing scheme for the cache? It's not very good right now. Well, I mean, I don't know how good it is right now because we haven't tested it, but it's not very good right now. It's not good for the cache or for SIMD operations. So like I said, I don't expect we will store things exactly this way when we kind of get to the end of the tunnel, if you will. When we would actually do some of those optimizations, I don't know. But like right now, if you're looking for cache friendliness, this is not going to be your friend at the moment. But also right now, we don't really want to be optimizing for cache friendliness because we don't even really know exactly how all of our operations work. So until we do, we can't really think about the cache very well. When jumping, you just need XYZ coordinates to make it happen, question mark. Yeah. I mean, jumping is just, like, we don't have a Z coordinate for our guy. Well, I mean, you can, yeah, I mean, I'm trying to think of what the easiest way, like, so jumping is just someone who gets some upward velocity and then has gravity, right? I mean, if we had 3D vectors, which I don't really want to throw in right now, but you could do it. I mean, one way to think about it would just be, if you wanted to do jumping, you'd just say, okay, there's like a Z value here, right, in high entity or something like that. And when you draw the guy, the place that you're going to draw him, like the player ground point or whatever, you just go ahead and say we're going to offset it by whatever the high entity Z value is, right? And so if I do that, let me see here. If I do that, right, then I should get exactly the same thing I had before, right? But now, if I go ahead and actually jump it, although you know what, let me do it in a slightly different place too. Let me do it actually here, just like that, right? Okay. So now, if you take a look at this, right, if we were to change that high entity Z, so let's say we took high high entity z and made it equal to 2.0f or something like this, right? And we still need, I guess I should also point out, we need to do z equals high entity z, like so, and we need to change that meters to pixels. So there we go. So we got our high entity z, so I'm just going to make that a z. So we're going to offset the bitmaps y by z, okay? And I can't remember, so we're actually doing our flip here, and then the draw bitmap expects the calls pre-flipped. Is that correct? Yeah, that's correct. So really, the z value is also negated, right? Because it's going upwards for positive z. So now you can see the guy's like offset from where he should be, right? And he's like a meter above, or 2 meters above where he should be or something, right? So there's where he is. So if we wanted to, now we could totally make the dude jump by just having, right, a velocity in z. That's all we would need to do, and hopefully it's clear like how that would work, right? It would work by going, for each entity, the high entity z, we have the, we remember the equations of motion. So the equations of motion that we had up here, right? Do you remember these guys? They're exactly the same if we wanted to do z, right? So you would just do exactly this. You'd basically have whatever the delta z is. So this is the delta z. It's going to be the square of the time step, and then it's going to be whatever the z velocity is times that, like so on, and the d dz, right? So this is the acceleration. This is the velocity. And then we've got that delta z. So, and to update this, we just have to take, again, that and entity, like so, right? So that would be, you'd update the z exactly the same way as we were updating everything else. That's why I say we should just use 3-dimensional coordinates, really. But you'd update the jump z exactly that way, and then what you do is say, okay, the high, this is the delta z. There we go. We don't want the high entity z to ever be less than 0 or whatever the ground height is, but we'll say it's 0 for now. So off we go, and then we need whatever the acceleration is in z, and of course the acceleration in z is negative 9.8 meters per second squared. Right, because that's the speed of gravity, and the dt is going to be what our game input is, our dt for frame, right? Where's our dt for frame? Dt for frame. Let's see. There it is. Input dt for frame. There we go. So the dz is the high entity dz, so there we go. And so I think that should now give us our dude. Okay. So he doesn't have any z velocity right now, and so all we really need to do is give him some z velocity. So if we went into our code here when we do our controller check, if we went and said, all right, if action up ended down, then we'll just say that whatever entity this is, controlling entity high dz equals, he's got some, he's just got some velocity, right, upward, right? And that's probably a bit too high of a jump, to say the very least. So there we go. That's probably too little of a jump. So there we go, right? And off you go. So that's really all. It's literally the same equations of motion for last time, just with gravity in there. And if you don't like, obviously the speed of gravity, that's fine too. I didn't actually check to see very carefully whether I had done it properly, but I think everything should be correct here, right? Whatever the square of the time step is, blah, 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 right? And yeah, and we're adding in. Now, the question of like, depending on the perspective, this is not really a correct, this is not really correct here. It's really hard to say. But yeah, you can then tweak these values if you wanted a stronger jump value, so he jumps quicker or not as fast or whatever, right? But that's it. I mean, that's all jumping is. And so hopefully you could see how that worked. It's exactly the same stuff we did from before. This is just the equations of motion. Here's the update to the position. In fact, we don't really need delta z in there at all. You could just look at it this way, right? So the new p is just equal to, is equal to 1/2 at squared plus t times v, right? So there's the acceleration, there's the 1/2, there's the squared time, just like we did equations of motion. Here's the t times the velocity, because there's the velocity, right? And here's the original position, p prime. And then the update to the velocity is just, okay, whatever the velocity, whatever the acceleration was times the time step, plus whatever the velocity was before. And then this just prevents him from falling through the ground, right? So that's the equations of motion for jumping, and there really isn't anything else to it. I mean, that's all there is. And then again, if you want to tweak those constants, that's fine. But that'll give him the parabolic arc as well. Now, I can double jump or triple jump, right? Because we haven't done anything to prevent that. So I can kind of fly him quite a ways away from where he should be. But, what are you going to do? So, yeah. I don't know that I guess we can leave that in there for now. We'll pull it out later, but that's jumping. Will we switch to some kind of sparse storage, for example, for the high-res entities? Yes, that's my plan. So my plan is basically to have like a small array of high-res entities and a large array of dormant entities. And I don't know if we'll have like if we'll have a separate storage for low, or whether the low will just be stuff that is operating on the dormant. We'll have to see, so I'm not sure. How would you handle jumping on a ledge or surface to adopt a new base height? Well, I mean, it depends on what you're trying to do. In this particular case, if I was going to do, if I was going to hack it in here, it would look very different than if I was trying to do something where I was really making a platformer. Like, this is not a game where people jump. Like, he will not really jump in the game. He's just going to bounce around as part of his animation. So he's never going to jump in gameplay terms. He's only jumping visibly, right? Just a little hop. So I'm not really thinking about that too much, but you could imagine making it so that, tiles, the different entities had heights, and if he was above that height, then you would go ahead and set his base z, like you would basically say, what am I standing on? What's its z? And that's my base z value. I mean, that's one way you could do it, but I'd have to, it would be dependent largely on what the game was and what I was trying to do. So I'm not sure I can really give a very good answer. This is kind of funny. Yeah. What do you think about physics for character or mob movement in a platformer game, meaning that I press right, but it starts to accelerate instead of just move? So I like that feeling. That's the way I'm doing it here. You'll notice that the guy has some startup time and some slowdown time. And I like that feel. I don't like instantaneous on, instantaneous off. It doesn't feel good to me. But that is a preference thing, right? That's what do you like your game to feel like, kind of a thing. And it also is a design decision. Like, some games want a little more swimmy feel in the controls, and some want more precision. So I would say you kind of have to think about you'd have to think about what you want. Now make him jump through the ceiling into the next floor. Really? really want to do that because we're not set up. This is not the appropriate place to be doing that kind of thing. I mean, we'd have to say how high the thing should be. Yeah, I don't want to do that right now. Why is he so huge? Well, because we haven't really scaled him down to how big we want him yet, but it doesn't matter because we don't, you know, we're not really at the stage where we care about that. So I kind of like him giant. But yeah, he'll be a bit smaller. I suppose he's really giant if we do this. But yeah, we will... It's kind of funny when he jumps. Anyway. Will the floor or area of the zones be flat, or will it have slopes and 3D zones, aka hills? Flat, always. The reason that I decided I wanted it to always be flat is because I don't like the way hills work in 2D games, really. They always annoy me. I've just always found them really, really annoying. Like, either they don't work the way you expect them to and it's annoying, or they do work the way you expect them to and they're annoying. Like, both cases are annoying. One way is like, I'm at the top of a hill and I'm trying to shoot down at someone and I can't because like the shot hits the ground or one or the other and like it's annoying. Or like it doesn't do that and so I think the enemy can't shoot me from there but he can, and like, I don't know, I'm never satisfied with hills. They just don't seem to work in in 3D they work fine because it's all kind of in a consistent environment. But in 2D, because you have this sort of hybrid of like, well, things are sort of drawn in 3D, but you know, it's not real perspective and it's not really transformed. You just get these conditions that I don't like, and so I flat out said there's no hills. I think Yangshin would prefer that there were hills, but there's not going to be any hills. There will be overhanging stuff, so there will be occluders like arches and stuff that you go through and stuff like that. I think there will be those, but there will not be hills. Can you change the yellow tile beneath his feet quickly and easily to be grayish and round so it looks like a jumping shadow? Completely not required, but why not? Yeah, I mean, obviously you could do that. So what you would want to do for that, so we've got the draw rectangle call, right? And really probably what you'd want to do is call draw bitmap instead. So like what you would do, did we put a shadow already in the data directory though? So there's already a shadow, right? So what we could do is just say, instead of drawing, if you don't like that rectangle, you could just go ahead and close it out and say that you wanted to draw game state shadow, and that'd just be fine. Yeah. So yeah, you get the idea. So you'd basically say that there's a shadow here, and then when we load the backdrop, right, we'd just do something like this, right? Test hero shadow. Let's see. Did I do that right? All right, there you go. So there's the shadow, right? Oh, right, and I forgot, that doesn't move. So the shadow should not move. The shadow should just be there, right? So then he's jumping, right? But what you want that, we don't have scaling in our rendering yet. So you would want that to shrink, that shadow to shrink. And so we could approximate that effect by multiplying through by the alpha. And we're really getting off topic here, people. But you know, why not? So if we added a C alpha in here, right? So we basically multiply our alpha value by some other value. When we come through here and we pick up the A value, right, we can go ahead and say that A times equals the C alpha. If we did that, then you can notice nothing changes. But if we then go in here and make that proportional to our Z value, right? So when we draw the shadow, we'll pass that C alpha value through here. And then what we do is we say that the C alpha value equals, 1.0f minus whatever the entity Z is, so that when he gets higher, the alpha value gets less, right? And then a C alpha, we just make sure that if that's greater than, if that's less than 0, we clamp it, right? So it doesn't get less than 0. And then you can kind of see, right, it feels a little more right. This is pretty, we're playing it pretty fast and loose here, but you can kind of, gives it a little bit better feel. But we'd want to scale it down as well as what we're doing here. So there you go. That's there's a shadow for you. If you wanted a shadow, you got a shadow. If you add walls in the middle of rooms, would they be handled as entities for the purpose of collision detection or separately? So what we're going to do, I think, and like I said, this is just me playing around, but I'm pretty sure what we're going to do, and this is what we'll be doing tomorrow, is everything's going to be entities in the active play field. So all the trees will be entities, the walls will be entities, everything will be entities. And when you move off the screen, they'll all get moved back to be the tile map. Let's see. Too fast. What is too fast? The fading out too fast? I should just quickly say what I did there in case you meant too fast for the explanation. So the person wanted a shadow, right? So all I did was I just loaded a shadow bitmap that we had and I put it down there, right? And so instead of drawing a rectangle, I drew the shadow bitmap. But when he gets further away from the ground, a shadow is caused by the light that's coming in is getting blocked by the person who's standing there, and so it can't hit the ground. But as he jumps, when he's further away from the ground, more light is able to get in at that ground patch that he is, so that he's no longer really occluding that area, right? And so as he jumped higher, I was just saying, oh, well, the shadow area should get smaller. And we don't really have the ability to do scaling right now. But what we did have the ability to do, right, is our draw bitmap function does alpha blending. So we already know that we have the ability to make things essentially translucent, right? I mean, we could make things translucent by just only blending, right, half the value, right? You can see that happening right here, right? If that makes sense. So because we have alpha blending, that means we have the ability to change how much of our source gets written into the destination because we were already doing this alpha blend right here. This was the alpha blend that takes the source and the destination and blends them using the linear, again, that linear blend equation that I said would be underpinning everything and always is. That linear blend equation is blending between our source and our destination. So it's blending between the guy and the trees, the forest bitmap in the background there, right? So all I did is said, well, okay, we were reading that alpha out of the guy's alpha channel. And that's what we were using to determine whether or not, each pixel, how much each pixel would be there. So that way where the guy isn't, we weren't writing any pixel data. And where he is, we were. And at the edges, we were writing a proportion of it, right? It's the thing that, if I zoom in here, I don't know if the zooming works still. Yeah. Can you, how much can you zoom in? Can you, there we go. You can zoom in a lot. That's kind of handy. So you can kind of see right there, like all around the edges of him too, right? That alpha blending is what's giving us that feathered edge as well, right? We wouldn't be able to feather the edge with the background without the alpha blending. So I just thought quick, and I was like, oh, well, if I want the shadow to kind of diminish as he jumps, well, that's the one thing I have to work with is the alpha blending. So I said, well, let's go ahead and just pass in a coefficient for the alpha here that I can pass from 0 to 1, and that will multiply whatever the incoming alpha is, right? And when it multiplies whatever the incoming alpha is, if I set it to like 0.5, then everything would be half blended, half as opaque. 0.25 would be a quarter as opaque, right? As it should be. And so that lets us vary the translucency of things, right, programmatically. And again, like I said, we already wrote all the code for that. All I did was just pass in a coefficient. That's all I did. And that was just to go ahead and get the shadow to do that little dimming effect. That's it. Hopefully that makes sense. How much has changing the rectangle to a bitmap instead of a rectangle impacted your player-on-player collision calculation? It doesn't. The player collision calculation will always be done on something other than bitmaps, basically. So the bitmaps are purely what we draw. How many zombie DLCs will there be? Well, I mean, I don't know that we want to do zombie DLCs. Because obviously, the most important thing in gaming is monetizing the player. Like, you don't want to think about stuff like whether the player's having a good time, or whether the game is fun, or whether you had an artistic statement to make that you wanted to make, or whether you loved it, or any of those things. What you want to think about is how to maximize profits. And so zombie DLCs, I don't think we're going to be able to squeeze the whales with that, right? I think what we really need here, we need a bigger harpoon, right? We need to harpoon the whales with something bigger. So I'm thinking like zombie DLC. Zombie microtransactions is what I'm thinking. So basically what we do is we charge 99 cents per zombie. And since we know zombies come in hordes, if the player wants to have any fun at all, they'll have to buy like a ton of them. And then Handmade Hero will just be like astronomically profitable. And that's the real important thing, obviously. Shouldn't you be doing this blending in a linear color space? Yes, and that is something we will talk about. Gamma, in fact, you want to see something that I have? When we talked about Gamma before, and I was lamenting that I couldn't find anything, well, guess what? My monitor actually came with its tested Gamma curve. You can actually see its candelas per meter squared here on the graph, right? I don't know if you can see that. Can you see that? So, yeah, when we get there, we actually have the monitor gamma curve on a piece of paper, which is kind of fun. But yeah, that's stuff to talk about in the render. We're not there yet. We're not at linear versus sRGB color spaces or any of that stuff, so we're not thinking about that yet. Let's see. When does the core mechanics of the game come into play? Earlier or later in the dev cycle? So on Handmade Hero, it is coming later in the dev cycle than it would ordinarily come, because this is a very educational project, and so I'm focusing on teaching different parts at different times. Normally, I would put the core game mechanics in right away. They already would have been in, right? But that is not really the primary goal of this game. The primary goal of this game is not game design, it's game programming. And so we will be going through a number of things before we start talking about core game mechanics, because we're not trying to iterate on core game mechanics, we're trying to iterate on game code, which is different. And so, yeah, I'm making concessions to the fact that it's trying to be more educational about programming, if that makes sense. So basically, game mechanics will come in after we finish the render, probably. Our rough roadmap is finish the rough version of everything, which is what we're doing right now, which isn't that long, maybe a couple more weeks. After that, we will go do collision detection, rendering, and audio output, right? Sound effects and music. And so the game will then be looking and sounding properly, but there'll be no game to play. And then we will switch over to the game mechanics, and we'll just go continuously with game mechanics from then on out. Because we got a lot of them. We got to do world generation. We have to do like entity systems and like interactions and a ton of objects and all that sort of stuff. So yeah, we'll basically, we'll spend a few months on engine stuff, and then we'll switch over to game mechanics, and I plan to then just stay on game mechanics the entire time from then on. Is there an easy way to translate from circle to ellipse collision detection? I'm not sure what that means. Minkowski will let you do ellipse collision detection just fine. It's a little bit more work than circle, but not much. So I'm sorry, I'm not sure I totally understand the question though. Do you recommend learning to make a game engine rather than using engines like Unity or Unreal for people new to game development? Well, it depends on what you want to do. If you want to be a game programmer, yes, I do. If you want to just be a game designer, then it probably isn't necessary. Although I would recommend gaining some familiarity with it. Meaning like, watching this series or something and just kind of seeing what goes on and maybe not having to learn everything, but just understanding sort of the things that are going on underneath the hood are very good to know, even as someone who's primarily a game design programmer rather than a game engine programmer. But you certainly wouldn't need to learn how to write a renderer yourself, but it would probably be good for you to understand how a renderer works, right? And so what I would say is it's all stuff that everyone should know, but it's a matter of what degree you need to know it, right? How much of each section. Do you just have a vague understanding of how a renderer works, or do you know how to write one yourself? If you're always going to be focusing on mostly doing game design programming and you're never going to write your own game engine, then you probably don't really need to be able to make an engine, make a renderer, right? But it would help you to know how one works and what's involved, because you're constantly involved with those systems when you're doing game design, and they constantly imply important restrictions and opportunities for you in your design, and not having any idea what's going on is constantly a hindrance. So what I would say is it's all good information for everybody who's involved in games, but the degree to which you really need to internalize it varies widely depending on what you plan to do. The rectangle box which you have alpha assigned, is that the same box you would assign hit points to in case the character is injured by enemies or obstacles? I don't know. Some games, like Legend of Zelda, I believe, is just sprite-based collision detection, so it's just whether the sprite gets hit. Whereas I think Binding of Isaac is actually sort of positional, so it's very 3D. Like basically, if a shot passed behind you like that, it wouldn't, or I guess I could do it with the properly occluded version here. If a shot passed behind you, it wouldn't hit you here, whereas in Zelda it would. I don't know which one of those is better. This one is more realistic, but it's not necessarily more understandable for the player, because then they have to kind of do this fuzzy math of like looking at where the shadow is, and so I don't know, like for this game, I really think I'm just going to have to try both of them and see which one feels better. Once the game is actually running and we're playing the game, I think we'll have to feel it and see. How common or practical is pixel by pixel collision check versus overall shapes collision check? Which one is more interesting to you? So pixel by pixel is totally doable. We could do it. The problem is it doesn't handle swept volumes very well. So things can tunnel with pixel by pixel collision checks in ways that you don't necessarily want them to. So that's the impracticality part of it. So what I would typically say is go polygonal and use a fairly tight polygon, because that's almost indistinguishable from pixel by pixel and can do swept volumes. That's what I would say. What are your thoughts on the Allegro library? I have never heard of or seen such said library, so I cannot comment. All right, I think we are done. The stream has ended if I'm not very much in error. Let's go ahead and close this all down. Well, yes, we are a little over time, but we're still, it all kind of fits together. It's fluid what time we end and what time we start. Thank you, everyone, for joining me for another episode of Handmade Hero. It has been a pleasure programming with you, as always. Basically, if you are the sort of person who likes to follow along with the source code at home, you can pre-order the game at handmadehero.org, and it comes with the source code. You can just go ahead and download it, and then you can play around with it yourself. Change the jumping speed, for example, if you want a faster jump or a slower jump or a higher jump even. You could do that, among other things. So if you want to do that, handmadehero.org, this is the handy dandy pre-order button, and you'll be able to download the source every night, and of course the test assets as well, and it'll obviously get you the game when it's ready. If you want to support the video series, we have a Patreon you can subscribe to. That's over here. And we have a news and forum site, which is pretty sweet. I highly recommend you check it out. It's got the schedule for the week posted. It's got an episode guide that has all the past episodes with like time markers and good stuff. It's really much easier to follow on there if you're trying to catch up. We have a coding resources page, and the coding resources page has ports to Linux and Mac already that other people have done. So if you're trying to run on a different system besides Windows, that's your go-to place. They've got it all up there. And finally, there's a code discussion forum where you can ask questions about the game code as it stands, or if you find problems or trying to get things compiling and you can't or whatever, that's the place to go. A lot of helpful people, and I answer questions on there too. So thank you very much for joining me. I hope to see you back here tomorrow night, 8 p.m. Pacific Standard Time again. We will have a delightful time, and we will start looking at pushing this a little further and getting our walls and stuff in. Maybe we'll start trying to add trees too. I don't know. We have a lot of things we could do, and they're all cool. So I hope to see you back here as the game starts to take shape. I'm pretty excited. I think we're getting closer to that cusp. We got to do the render. That's a big one. So obviously it'll take us a few weeks to do a render, I'm sure. But that's one of the last big things before we start being in Game Town for real. So I'm pretty excited. Thank you so much for joining me. Hope to see you tomorrow. And have a wonderful Wednesday, whether I do or not. Thanks, everyone.